Hello all, good morning and welcome to today's workshop on the topic AWS Serverless AI. My name is Bismillah Kani and I'm working as a senior data scientist at Vehicle Data Solutions. And about my background, I am an expertise in computer vision and deep learning. And I'm also an AWS certified solution architect associate. So I also play a dual role of solution architect to take the AI models to productions in cloud environment. And I was also associated with the CellStrat in developing a computer vision course and doing workshops, and which I love to do. And this is my first workshop for this year, and I'm so excited about it, and really happy, like a lot of people joining. So yeah, let's get started. So this is the agenda for today. We'll keep the agenda simple and we will do as much as hands-on as possible. So first we'll start with an introduction to the concept of serverless, and then we will look into what is SAM and how does it makes the deployment of serverless application in AWS Cloud easier and consistent. And then finally, we'll give you a sneak peek, preview of the newly launched SageMaker Serverless inference, which is the newly added a service into the serverless, and especially in the domain of ML and AI. I'm not sure how many of you know the concept of serverless. Probably you would have attended previous sessions in CellStrat and you might all know. But for the folks who who are new to the concept of serverless, I'll just give you a brief introduction. When we say serverless, what we mean is that it doesn't mean that there is no servers running. Yes, there are servers, but you do not have to provision and manage the underlying infrastructures. So all those abstractions are taken care for you. All you have to do is to develop your code. Either it could be a machine learning model, it could be some computer vision model, and then just deploy this code into the AWS cloud as a serverless applications. So it is a practice of using a managed service with event-driven compute functions. So it serverless, sometimes they are also called as function as service, and it removes the burden of the developer to provision and maintain the infrastructures, and it takes care of the underlying operations, configuration, and maintenance. Another advantage of serverless is that you only pay for what you use, so you are not charged for the ideal runtime. So it is also very cost effective solution. It also, the time to deploy this is much faster than the other way of deploying. So if you go, for example, in AWS, if you want to deploy a container in EC2 instance, an EC2 instance in AWS is an infrastructure as a service. They only give you, you are provided with only a bare metal virtual machines. Okay, you are responsible for installing the OS, or configuring what OS you want, what other library packages you want, and all the network configurations, the scalability, availability, and fault tolerance, all is the responsible for you. But in serverless, you don't have to worry about all those things. All you have to do is deploy your code into a function. So it is a very fast approach, and also in terms of sustainability, This doesn't run all 24/7 as compared to other EC2 instances. So it will only run when it is needed, which means that it also gives it is interesting in terms of sustainability, because when a virtual machine is running, it is kind of contributing to the CO2 emissions, right? So if you are not using it, then you just shut it down, and then you are indirectly or directly contributing to the sustainability also. Okay. So when we come to AWS, what are the serverless services AWS provides to us? The main service, serverless service provided by AWS is centering around Lambda. So Lambda is an event-driven pay-as-you-go compute service. So it comes under the compute service. What are the compute service AWS provides? It provides EC2, it provides ECS, EKS, like containers service. And our EMR, like running your Spark jobs. So Lambda is one of the compute service, and what is good about Lambda is it is in serverless, and then you don't have to provision or manage any infrastructure that is required to run your application. All you need to do is develop your code and deploy it, and that is why it is called as function as a service. And another serverless service provided by AWS is a Fargate. So this Fargate is to run your container workload. So for example, if you want to deploy your container into cloud, when you deploy it in Elastic Container Service in ECS, you have two options. Either you can deploy it as a Fargate thing, or you can deploy it as an EC2, which means that when you deploy it as a Fargate, it becomes a serverless, and you don't have to worry about managing and maintaining your underlying resources. And then there is application integration services like API gateway, event bridge, step functions. So API gateway is an interface between your client application and your Lambda functions. And event bridge is like the event based, you can configure your events. So the events could be like a schedule, or it could be an API gateway trigger, or it could be like some S3 events. So any events possible could be configured using event bridge. And step function is an visual workflow orchestration. Suppose if you have applications that has many microservices that are deployed as in Lambda functions, and they have a logical workflow within it. So you can actually configure this workflow using step functions. And SQS and SNS is a service for decoupling your microservices. So SQS stands for queue services, and this is a notification services, which means that when there is a request coming from your client, and it is queued up into the SQS, and then it can be asynchronously invoked. The application in a Lambda can be asynchronously invoked from this SQS. So if any problem happen in your downstream applications, if your application goes down, your requesters are still retained in these queues. And once the application comes up again, the application will start pulling the request from these queues and then give the response back, which means that the user will not get the service unavailability error. Only thing is they might face some delay in getting the response, but when the application again comes back, their queue is not missed out, or their request is not missed out, they will get the response back. And also in the data store, we have S3, very popular, they are object storage, and DynamoDB is NoSQL key value pair storage. And now coming to the main topic is the SAM. Now when you want
Bismillah,
to
one query I have.
Yes.
So, can we give the request to the Lambda with the help of the mail, because we have seen that generally we give the request to the Lambda mostly with the request with the API or with this particular time slots on jobs. So can we give the request, or can we trigger the mail? Can we trigger the Lambda with the mail or something like that as well?
I have to explore, but we will see in the workshop also. We will see whether there is an option to add a mail as an one of the events.
Yeah. Okay. Sure.
Okay, I just park this question. When we are
Sure.
going into the cloud, we will explore this.
Okay. Fine. Thank you.
Yeah. Okay. So coming back to the today's topic is the SAM, and so SAM is it's an extension of the cloud formation service by the AWS. And what is cloud formation? So cloud formation is an deployment automation tool, or slash you can also call it as infrastructure as code. So when you have an application and if you want to deploy it, um, uh, 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 you cannot go and deploy it through the management console. So you cannot go open services one by one and then using the user interface, selecting all the options and entering and configuring. You cannot do it. It takes a lot of time to do, and it will also be error prone, and and it will be like difficult to manage, and also it will be not suitable for CI/CD pipelines where you want to do continuous rollout, for the upcoming versions. So CloudFormation is the tool AWS provide for this deployment automation using infrastructure as code, which means that all the infrastructure resources that are required for your applications are deployed through a YAML template. So it is a declarative programming format in a YAML. You declare all the resources and also the properties of each resources and how and other configurations. And then when you deploy this YAML template, all the resources are created in the AWS account for you, and your application is up running. And SAM is an extension of CloudFormation template and focusing mainly on serverless applications, and that is the name, serverless application model. So it is used to build your application and deploy your application. And with just using a few lines per resources, you can define your application and deploy it using YAML template. So also like you don't have to write the YAML template on all by yourself. You can also use the SAM CLI commands, and this YAML template is automatically created for you. And yeah, so SAM transforms and expands the SAM syntax, which is the CLI commands, which we will see it in the hands-on. They are transformed into a CloudFormation syntax, that is the YAML template, and then it will then your application is deployed into the AWS cloud. Finally, the final agenda for today is to have a sneak peek into the serverless inference that has been launched in the November 2021 in the reInvent conference, AWS conference. So this is a new addition to the the type of inference SageMaker has. So SageMaker has essentially 4 types of inference. One is a real-time inference. Second is the batch, asynchronous, and serverless. So real-time is, as the name says, if you want a real-time response for your machine learning and AI models, and this is the instance or the endpoint you have to use. So they meet the low latency requirements. But if you have, let's say, like thousands of inference has to be happened. Let's say you have like thousands and 10,000 images, and you want the inference of all these images, then you can actually do a batch inference. For it is mainly meant for large data set. And then last 6 months back, they introduced this asynchronous inference, which is as the name says, it does an asynchronous invocations, which means that when there is a queue up to your SageMaker endpoint, this real-time inference can only do synchronously, which means it will do sequentially, take one image at a time and then run it and then give you the result back. But let's say you have like 100 images in your queue, then you can asynchronously do those inference, and then it does a parallel processing of all those 100 images and does a concurrent processing, and it will give you back the result faster than the real time. But it is not meant to be a single inference will not be as real time as the real time inference, but it is mainly for when there is a queue up and you want to clear this queue faster, then you can use this. And then latest, today what we'll see is the demo of serverless. So as we know that when you are deploying an endpoint as SageMaker, it is charged hourly basis. Okay, whether you are using it or not, you are getting you will pay for the active endpoints. So if your endpoint is running 24/7, and if you are using it not most of the time, then your cost of your endpoint will be very high. And serverless can be a very good choice for such intermediate unpredictable loads for your model. Then you can deploy it as a serverless, and then you only get paid, or you pay only for the invocations that is happening. So it is similar to the Lambda. So this is a Lambda version of SageMaker. Okay, so that's it. I will start with the demo. If there is any questions, before we go into the demo, I'll take it up.
Hi, Bismillah. I have a question.
Yeah.
So basically, I wanted to know if there is GPU support for serverless.
No, as I said, it is in preview, so there is no GPU support. But you can expect it to come in future.
Okay, sure. Thank you.
Okay, and I have actually created a code repo for today's session, and there is also some pre-request. So let me pull my Okay, so this is what we will do in today's hands-on. Okay, and I will just put this link to you, but we will do the all those steps one by one, and we will see it. So this is the what is the plan for today's workshop. Okay, so we will do two things. One is SAM and SageMaker. So before that, I want to give a quick demo of what application we are going to build today. Okay, so just give me a minute. I'm just pulling my application. Okay. Just give me a minute. Okay. So one is a very simple MNIS digit classifier. So we will deploy that as an serverless application. So now it is already up. I had deployed it previously. I'll just give you a demo. So what is this doing is like when you upload an image, it will do the invocation and give you the result back. So for example, this is an image that I uploaded, and when I send the request, so it will do the prediction and give me the result. So now I can upload another image. Yeah.
Can you take a step back and start from beginning? What are we doing?
Yeah, we'll do it. I just give you a demo of what to expect from today's. So I will do it one more time, but I just giving you. So giving you the final outcome what it should be, so that we are going to work backwards. So what I have done is I have deployed that MNIST classification as an API into the Lambda, and there is an API REST endpoint. And in using the Postman, I came here, I entered the API URL. It's a post request, and then I uploaded an image. Okay. And then I'm sending that request to my API gateway, and then it is doing the prediction and giving back the result. Okay, this is one application. This is a very simple application. I am misclassified. Another application what I want to show you is somewhat advanced. So I just don't want to leave you guys with some this very simple thing. So I want to do some a little more exciting things. So what we'll do is we'll deploy an application called ClipCrop. And what this will do is when you give a search query as a text input, it will search for that object in the image, crop that object, and give you back the cropped object. I think you might have heard about this ClipCrop. Okay, so when you run this, so I have already deployed it. As you can see, it is an API URL, and I'm giving the image URL and my search query. Okay, and then I'm invoking it. And what it does is it takes this as an image, and then I want to search where is there a dog in this image, and if there is a dog, it is going to return me that. Okay. And yeah, that is the demo. Like, you can also try, let's say I want to search a blue jacket. And let's try that. Okay, so I have not given person as an input. I said blue jacket, but it was able to find the semantic correlation between this object and the blue jacket as a text input, and it did return me the cropped region of that image. So this is the application that we will do. So we'll also go into the code and see, but I want to go directly into the deployment, and then we'll follow all these steps that I have given in this repo one by one. And then if you have an account and if you have already done this pre-request, you should be able to do it by yourself. If not, it's okay, don't worry. You can watch me doing it, and then later when you find time, you can watch the video and try it for yourself.
Bismillah, this can also install on Linux shell.
This CLIs, yes.
Yeah. So what about using CellStrat Hub terminal for this purpose? Is it possible, you think?
Yes, I think so, but I have not tried it. But there
how
is
much space it will take, whether on a local computer or a Linux terminal in CellStrat Hub?
no, it will not take that much. So it is just a CLI tool.
So both Windows and Linux versions are supported for all of them, right?
Yes.
So folks, you can install these on your personal computer, or if you want a Linux terminal and don't want to use your personal computer space, you can attempt it in CellStrat Hub terminal. It has 8 GB of space in the free tier.
Okay, awesome. Yeah. Okay, guys. So the prerequisite is that you have to have an AWS account. Uh, so how many of you have already have an AWS account? Okay, so I see some already have it. Okay, so then you have to install AWS CLI tool, um, and you have to install a SAM CLI tool. Okay, and you should also have Docker installed in your system. Okay, so these are the three prerequisites to be done. And yeah, you need an AWS account because then only we can create resources. You need a CLI because that will give you the authorization to run these commands and create resources from your computer. And SAM CLI is the framework that we'll be using it for creating this and deploying the application. And since we are actually deploying the application as a Docker image, we also need a Docker because we'll be building the Docker image. Okay, so now I'm going to start. Okay, once your prerequisite is completed, what are the steps to be followed? So what we have to do is we have to clone this repo. Okay, so this is the first step. So be careful. I have included recursive here, so don't just clone this repo because there is another GitHub inside this repo. So you have to do recursive, then only you will have the entire code. Okay, I have copied the command. Okay, so now in my desktop I will create a folder. Okay, so I will call it as workshop. Let's say call it as live, right? And then I am actually going to open VS Code, but you can also open any terminal you want. I'm opening VS Code because I can also show you the code. Okay, so now I am into my workshop live. I'm going to open a terminal here. Okay, I hope you can see the terminal, and then I'm going to clone my repo here. Okay, so you see the entire code repo has been created for me here. So now the next step would be to deploy one of we'll first deploy the simple model, which is the digit classifier, right? So now we have done that. So what is my next step? So you go back to my, I think this one is okay. So now we have to create an IAM user. Okay, because we need permissions to authorize and create resources on your behalf. So for that, what we have to go to is like we have to get into the AWS console. So I'm getting into my AWS. So what I'll do is I'll close all this and I will start from beginning. Okay, so that you all can follow me. Okay, so now I am into my AWS console. Okay, I'm in Ohio region. First step I want to create an IAM user. So for that, what I will do is I am going to my IAM service. So here I want to create a new user. Okay, so now let's add a new user. So now let's call it as Serverless Workshop live, like that. Okay, and then select this access key, which gives you a programmatic access, which means that you will get an access key ID and secret access key for all your AWS CLI tools and SDK and CDK tools. Okay, and next step, you have to add the permissions for this IAM users, and that is where you have to again refer my document back. What are the IAM permissions you need? So you need 1, 2, 3, 4, 5, 6, 7, 8. So 8 IAM permissions you need. First is you need to have an IAM. So here I am being a little bit liberal. So I am giving all full access, but it is not a good practice. You should follow the principle of least privilege recommended by AWS. But yeah, for making it easier, I'm just giving full access. So then the main thing is we need a Lambda full access. Right? Then we need API gateway, because that's what we will select. So it's API gateway administrator and also full invoke. And we need, of course, the cloud formation, because your is created through cloud formation. And then your Docker image is pushed into Elastic Container Registry. So yeah, I can just copy this and put there also. Okay, and then yeah, I also need S3 access. Okay, and then I need CloudWatch, because if something is not going correct, I want to do some debugging. And I want event bridge, because I want to create an event configuration for my Lambda invocation. Okay. So then I click next. It's an optional, you no need to give any tags. So I have IAM, Lambda, API, CloudFormation, ECR, S3, CloudWatch, Event Bridge. Okay, and then I'm going to create user. Okay, so now we have the access key and secret. Please do not share this with anyone. So I'm showing it, but I will delete it immediately after this workshop. So you can download this and let's put it here. Okay, and then yeah, I'm just going to remove this, and yeah, I hope it doesn't matter. Okay, so you cannot see the access key and secret. Okay, so now what we have to do is we have completed the second step, right? So actually 3 steps you have completed. We have cloned the repo, we have created an IAM user with these permissions, we have created a programmatic access by creating access keys and secret access. Okay, we have completed these 3 steps. Okay, any or are you able to do it, or are you doing it? If you're not doing it, you can also do it later, but I'm just taking stock if anybody is having issues.
So audience, you can follow the GitHub instructions and step by step and try to do it. For the CLI installation, you have a couple of options. You can install the CLI on your local computer, Windows or Mac version, whichever one you are using, or you can You can install it in CellStrat Hub. Just open CellStrat Hub, create an account if you don't have, and open a terminal. You can do the Linux versions there. You'll all have to create a personal AWS account, enter your credit card most likely. But before end of this workshop, you can stop the services in AWS so that your card will not be charged and you'll be within the free tier of AWS.
Okay. Yeah, so there was 2 questions. Can you tell how to download software in CellStrat Hub? Yeah, if you're a new user to CellStrat Hub, so you have to create a user account in CellStrat Hub, and then it will in the free tier, I think you can. I was no new user. Oh, okay. So then I think once you launch that workspace and open a Jupyter notebook or a Jupyter lab, and then open a terminal, and then it is an Linux terminal, and you can install your applications using Linux commands. Okay, is correct, right, Vivek?
Yeah, Bismillah, that is correct. And the rest of the process will remain exactly same, right? Am I right, Bismillah?
Yes.
Okay. So, folks, you can use personal computer to install the 4 CLI software, or you can use the CellStrat Hub Linux terminal. After that, the process would be similar. You'll still need a personal AWS account, I guess.
Yes. Okay. Are these only for paid AWS, or can we use this for personal AWS? Yeah, you can use for personal AWS account. So I would recommend you can stop, with that simple, MNIST digit classifier application. Because in because in the AWS free tier account, you only have 500 MB of storage for your ECR, but this ClipCrop application might cross that 500 MB, and that is why I'm a bit reluctant in not use the ClipCrop in your free, but it will not charge you much. It will be like kind of acceptable amount. But let's take a free tier account. If in the free tier account we are using, let's say, for Lambda, right? So for Lambda you will be getting 1 million free requests per month, but this is on okay, so this will if you have a free tier, and for this workshop you will not get charged because you have enough requests per month, and you will not get charged for it. Okay, that is one. It takes care of the Lambda. But when it comes to ECR, that is the where you might get cross the this okay. See, you can see Elastic Container Registry. You have a 500 MB per month of storage, but I doubt whether it will be in 500 MB. I think it will be more than 500 MB. So that is why I'm saying not to do that. So otherwise, SageMaker, you also have free tier account, and also more or less this is in serverless, so you still have like 2 months free trial. Okay, so if you have opened it today, you still have 2 months of free trial for SageMaker, but after that you will get charged. Suppose if you have created an account before 2 months, then if you're doing the workshop today, so you will get charged for that. Okay, So that is a little bit about the cost that you might incur. So somebody has raised a question. Deepti, you raised your hand. Maybe you can, feel free to unmute and ask your questions. Okay. Okay. So if all is okay, if you have a free AWS account, if you have installed CLI, SAM, and Docker, and if you have created an IAM user, and if you have this programmatic access, and then you're all good to go. So now let's start with things. Let's go into my terminal. Yes. So now what I will do is, now I have to configure my AWS. So what I'll say is, first you have to say AWS configure, then it will ask for your access key. So now what I'll do is, I'll just go off the screen and then enter my secret key ID, and then I'll come back. So enter your access key ID, and then enter your secret access key, and then enter your region. So I have selected US East 2 as my default region, and then go. Yeah. So now I'm going to clear my screen, and then I'll come back here. Okay. So now what I have done is I have configured my AWS, which means that I can now create resources from my command line. Okay. So that is my second step. Now going back to my instructions. So now what we are doing is, we are going to deploy the digit classifier application. So now I have to change my directory to this. Okay. So I'm going to change to SAM. AWS Serverless AI, and then into SAM, and then into my digit classifier. Okay. Once I am there, I have to say SAM build. Okay. So SAM is the CLI tool that is going to deploy your serverless application. So if you have installed SAM into your system, whether it could be a local PC or CellStrat hub, you just confirm whether your SAM is installed properly by checking SAM -- version. So you can see the SAM CLI is installed, and you can also see what are the commands available for the SAM. So this is the main topic. So if you want to learn SAM, you have to focus here. So SAM is a serverless application model, and these are the commands. So it is like init, so which means that when you say SAM init, it will create a serverless application repo for you here, and then you can start developing your model, start writing your code. And then once you are ready for deployment, and then you have to run build command. So which means the SAM will build your application as a Lambda function code. And then another important command is the SAM deploy. So once you say SAM deploy, your Lambda functions and other serverless resources are created into your AWS account, from your command line too. Okay. So there are other commands, but probably you can explore on your own. Okay. You can even delete it after. So it's very simple. So now we have our applications, right? So now let's take a look into what our application is consists of, right? I think that's a good thing to do. So if you open this digit classifier, so we have application folder and some additional things like events folder. You can use it for some testing. And I have some, I have uploaded. So I have some test images to test my application. And I have a template. This is my CloudFormation template, or the SAM template actually. And yeah, just ignore this. We are not doing any training. And the main thing is in this application folder. And this is my application code. So what this application code looks like, it is in Lambda function. And this Lambda function, what it does is it takes an image and do a digit predictions. So as you can see, there is a model. Okay, we are loading that model. The model is, the trained model is here. And we are using Torch, PyTorch. This is a PyTorch model for you to say. And then we are taking the image bytes, doing the predictions, and then giving back the label which number it is as a inference result. This is simple digit predictions. And then another important thing is to know about is what is your Docker file is composed of. Okay, it's also very simple. It takes the base image from the Amazon base image, the Python. Okay, and then it copies the application code and the requirements file into my work directory, and also copies my model into this folder and install all the dependencies in my requirements file. So what dependencies do I have? So I have Torch Vision, and also Pillow to do image reading and doing some image processing. Okay. So your application code, your Docker file, and your model file, and your requirements. These are the 4 things that are there in your application folder. And then the SAM will actually create this template, because since I have already created and pushed it into this, so it is showing you. But this is how you can also write this template on your own, but SAM will do it for you. Okay, so then this will be created as a resources. So now let's go and run the SAM build and see what comes out. So in order to the second step is to build your applications. For that, you do SAM build. Okay, since it was a very simple application, the SAM, the Docker image was created, very fast. If you are familiar with Docker image building, you can see the steps, right?
So Bismillah, all these steps are listed in your GitHub README profile, right?
Yes. So now what we did was we did SAM build, right?
So if we follow the GitHub README profile, we will be able to do all these things one by one.
Yes. So maybe a recall. So what we did is we did a cloning of this repo. Once we cloned it, we have this entire code base with us. And then you have to create an IAM user. I also showed you how to create an IAM user with the required permissions, and how to create user access keys, right? And then how to configure the AWS, right? Just this is a command. You just go to a terminal and say AWS configure. It will ask for your access key and secret key. You enter it, and then you are now set to go. Then go into the SAM digit classifier folder. Now how I am here now, right? I am in digit classifier folder, and then run this SAM build command. That is what we have done here. So we have completed up to step 1 to 6.
Bismillah, I have a quick question.
Yes.
So what is the standard for computer vision APIs? Is it passing it as a base 64 string, or is it like a byte array that you're doing? And what are the advantages versus disadvantages between one versus other? Thank you.
Right. So yeah, there are different ways. Like you can create as a byte array. You can also give it as image URL, right? or you can upload the image to the S3 bucket and then give the S3 path to your invocations. Yeah, it depends on how you want to design your applications. For user, he is not interested to know all these things. Mostly, in CellStrat AI platform, I think you are familiar with it. So what we did was the user will log into the CellStrat AI platform and he will upload the image right from his local. And then these images are actually uploaded to our S3 bucket, and then from our AI model will pull these images from the S3 bucket and do the inference and give back him the result.
Got
Yes.
it. Thanks. And just a quick follow-up. So when you deploy this, is there cold start time? Because this is a heavy model with torch and everything, right? I mean, not very heavy, but at least. So for Dockerized deployments with SAM on Lambda, are there any cold start time, and usually how much is it?
Yes, cold start is there. I'm not sure how much it is. Yeah, there will be a cold start whenever there is a Lambda, or even in SageMaker Serverless, there will be a cold start. But I have not done any benchmark of how. I think it depends on your model size, how big is your model.
Got it. Thanks a lot for answering. Thank you.
Yeah, welcome. Okay, and right. So I think we have completed up to step 6. Now is the main step. We want to deploy the model. So when you are doing a SAM deploy, you can use this option called guided. I think I have mentioned it there. I'm not sure. Yes, I have mentioned it. Okay, so you can say SAM deploy guided. Then it will ask you, questions. What should be your deployment configuration when you are doing for the first time as a beginner, or deploying this application for first time. You can use guided, but when you are doing it for the subsequent deployment, you can save this deployment configuration as a configuration file, and you can just call SAM deploy and it will take that deployment configuration and it will do it. For now, we'll do SAM deploy guided. And okay, so then it asks for you an application name. So let's say we'll do MS digit classifier. So we'll keep it like this, and then we will say what is the region. I want to deploy it in US East 2, but you can also deploy in another region. So it asks whether you want to confirm before you deploy. You can say yes. Allow CMI to create roles, IAM roles for you. Yes. You want to disable rollback? No. What is the rollback? Which means that when you are deploying your application through CloudFormation template, and your application stack can have different components, okay, and it could be the case that like first few components are created successfully, but the further components creation could fail. Whether you want to keep the first few successfully created resources as it is, or you want to roll back and complete or delete your stack completely, and then you want to start again. So I want to keep the rollback option, so I don't want to disable, so I will say no. Inference function may not have authorization. Is this okay? Yes. And then yeah, I'm not going to save the configuration, and then it is going to create a resource. So it will ask whether it is okay to create your easier repo for all the functions. I say yes. So now it is what it is going to do is it is going to push my Docker image into my ECR. Okay. As you can see, it is pushing my image into my ECR. So meanwhile, there is some questions. Can you keep an introduction mainly so we can study by ourselves? Do you mean that you want to give an introduction to Docker?
No, no. Can you give an introduction to Docker? I was asking.
Introduction to what Docker is, right?
Yeah, yeah, yeah.
Okay, okay, okay. So Docker is it's about like how to deploy your application as a container. And what is an application container? Means like you can package your application code and its dependencies and the underlying OS all into one container. And then the advantage of containerizing your application is that it is repeatable, and it is like portable. It is very lightweight, and and like it makes the deployment consistent and reproducible, because all your dependencies are kind of packaged. So normally what you do is you spin up an virtual machine, and then what you have to deploy your OS, deploy all your dependencies one after another, and then it could be that some dependencies are not installed properly and your application will crash. But when you containerize your applications, it is for sure it will work in whatever the deployment environment it is, whether your deployment environment is development or test or production. It is guaranteed to work across all the environment when it is working in development. So previously there will be a case that my application works in development but it got crashed in production, like that. But that kind of issues will be solved by Dockerizing your application. Okay, so now it is asking for confirmation. Should I create my resources? Okay, so this is now where the cloud formation will coming into it. And what are the cloud formation stack we are going to create? We are going to create an inference functions, IAM role, an API, and then the staging for your API. Okay, so now we'll say yes, and as you can see, it is creating in the background. Meanwhile, I'll just explain you like what did we created here. Okay, so what we have is like we have our application into our Lambda. Okay, so our application is going to be deployed as a Lambda function, but this Lambda function needs your container image. So your container image, your Docker image will be deployed in your EC2. Okay.
So just a question, is it for using Lambda, is it always important that the application should be Dockerized?
Yeah, why we want to Dockerize it? Because yeah, if you want to install without a Docker into the Lambda, then you have to install all your dependencies, right?
Packages, yeah, correct. But both ways possible, right? In case you don't
Both
know.
ways is possible. So dependencies, we need Torch. But if you want to install Torch manually into the Lambda runtime environment, then yeah, you can go and do it manually. But I am creating a Docker image because then all my dependencies are taken care.
Yeah.
So my applications, need this. So this is my application. So I build my Docker image, right? So this is my Docker. I pushed into my ECR, my Docker repo, and this is my application, right? This is my application. This is my app. So now I have deployed my app. Now I have a user. Let's say there is a user, okay? Now he wants to use this application. So in order for the user to interact with the application, I need a API gateway. So this is my API gateway. And what it will do is the user will send the request. Okay. And the API gateway will invoke my application. My application will take the request and process the request and give back the inference result. And then the API gateway will give back to my user the response for his request. This is my code actually. And as you can see, this entire stack is actually deployed into AWS. Okay, sorry for my. So this is in AWS, and we actually deployed this stack using SAM. So this entire stack has been created for me using SAM. Okay, this is what we achieved this today. Okay, any doubt in this diagram?
Hi, Bismillah. So if we want to introduce some asynchronous in here, how do we add a queuing system in this diagram?
Okay. So let's, I'm not sure. Okay, where is my file? Yeah, so, oops. Okay, I'll just keep this diagram. And what we'll do is instead of API gateway, in between probably, we have to add a SQS queue. Probably we have to add an SQS queue, right? And what will happen is the API will forward all the requests to SQS. Okay, and in this SQS you will have the your request queued up like this, and then you have your Lambda, and then there can be an asynchronous concurrent invocation, so all the requests can parallelly processed, which means that all the scaling up of the resources of this Lambda and running the request concurrently is all taken care by the AWS Lambda services itself. So you don't have to worry about it. All you have to do is you have to configure the asynchronous, the concurrency of the Lambda, and then you have to attach an SQS queue in between. And you also have to configure now what they call timeout for this SQS. Now what is the life cycle of a message inside this SQS, and whether you want first in first out queue or you want a standard queue, all those things can be configured. Does that answer your question?
Yeah, thank you. And just one follow-up is, so using ECR versus installing these dependencies like Torch, etc. on Elastic file system. So what are the pros and cons of both? You can have shared Elastic file system to Lambdas as well, right?
Yeah, that is also another way. There was also a previous workshop done by Bhavesh on this. So he has done a very detailed walkthrough on this using EFS for installing these dependencies. But I felt like this is much simpler comparing to that. And you have to then, if you are using EFS, then you have to configure, you have to create a VPC, right? Then you have to create subnets, and then you have to attach your EFS to that, and then your Lambda also should be in the same VPC. So you have to do a lot more overhead configuration than this, right?
Got it. Got it. Thanks. Yeah.
Yeah. Okay, so now we have deployed this, and similarly, like how we showed you in our initial, where's my Postman thing? Yeah. So initially, how I showed you like how to invoke the things, your you have to paste your API URL, and just select binary and invoke it. Now we also go and see the stack, like how it has been created. I think that is very interesting. So now we have created a stack called MNIST digit classifier. Okay, so what are the stacks we created? We created so we created an IAM role, we created a Lambda function, we created an API gateway. Yeah, that's all the things we created, and the supporting permissions. As an output, it gave you the API URLs and the ARN for your your IAM roles and ARN for your Lambda function. Now, how let's go into our cloud and see how these are created. Okay, so now let's go to Lambda. Let's go to API gateway. Let's go to ECR. Also, let's go to CloudFormation. Now, this is all done through CloudFormation stack, right? So now you can see my entire stack has been created for me just with a single command of SAM deploy. In this stack, these are the resources created. So this is also the same that has been printed in your command line too. All those IAM role inference functions. So this gives you the history or the events for your CloudFormation thing, and what resources are created, a function, a role, an API gateway, all these are being created for you. And as an output, the API URL, function ARN, role ARN is being provided to you. So this is how they use in CloudFormation. But you don't have to go and create this template and then create the resource. SAM takes care for you. Okay, and you also have a companion stack. Okay, for this is nothing but your ECR, your container registry, that is also being created. Now, if you go to ECR, you can see that the MNIST digit classifier repo has been created for you, and you have the latest Docker image created for you here. And this is the Docker image that your Lambda function will use to deploy your application. And now you can see MNIST digit classifier function has been created for you 9 minutes ago. And if you open it, it will tell you that this is the image I am using it. Okay, this is the ECR image link. And yeah, the API gateway event is already been created for you, so you don't have to create. And all others, configuration is been created for you. Even how much memory you want, what is the timeout. If you actually see in the template, this is are being configured for you, right? So you can also modify this. Let's say I want 10 GB RAM because my model is heavy. I want a timeout of, let's say, for 5 minutes, not like 16 seconds, then that is also possible. Okay.
A quick question, Bismillah. So
Yes.
regardless of our timeout for Lambda function, if we route it through API gateway, I think there's a upper limit of like 30 seconds, right? So we have a bottleneck there regardless, right? Let me know.
Yes, correct.
Okay.
So as Sri mentioned, even if I have like here 5 minutes timeout, my API upper limit is 29 seconds. So it will, give back a timeout error. Okay, if my Lambda processing is not completed within 29 seconds. So in that scenario, you have to configure it as an async invocation for your API gateway, which means that your API gateway will not get a response back from your Lambda. It will just invoke, and then it will, it will not throw you any timeout error. But in the back end, the Lambda will process it. Even if it takes more than 30 seconds, your processing will be completed, and you have to somehow store your results in, let's say in DynamoDB or somewhere, and then give the result back. So you have to do some kind of, routing and configuration. Is that correct, Amsri?
Thanks, Bismillah. Yeah.
Okay, awesome. Right, so you can also do some testing right from here, but yeah, since we are doing through Postman, that is fine. And yeah, we also created the API gateway, you can see here. And yeah, this is my staging is also been taken care for me. This is my API URL. Okay, so now this is all done for you. Okay, so as also, what did we cover so far? Where are we? Here. Okay, here. Okay, so we have covered till step 8. I think we have completed the digit classifier stack, right? We have deployed this stack using our SAM, right, with just 2 commands. Okay, so I will just leave you this ClipCrop application as a homework for you. Try it, on your own. There is some extra steps required. You have to actually download this weight, the clip model weight, and then copy it to this, and then you follow the same step, build and deploy. And then there is also a test API script that is created for you, and you can test your model. So that is what we tested at the beginning of this workshop, where yeah, here it is. So you can just give your API URL here. Once it has been deployed, give an image URL that is some interesting image, and then give a search text, and then it will just run the inference and give you back the cropped image for you. Okay, so that actually completes my part 1 for today. Okay, that was the major part, and our second part is the SageMaker Serverless. Okay, so for this, I think it's relatively easy compared to SAM. So now what we will do is we will go to our AWS console once again, and you just have to go to SageMaker. Okay, and yeah, before that, probably I will give you an insight of why this SageMaker is interesting for us. If you actually look into the SageMaker pricing, you will come to know why this is interesting. Now let's take a real-time inference. If you're using ML.M5, you'll be charged like 11 cents per hour. Okay, And if you're running it for 24 hours, it will be like some dollars for you. But in comparison, if you're using serverless inference, then as you can see, it is charged per second. And if you are not using it, you will have zero cost. So it is like a similar pricing, like how the Lambda does. So you don't have to worry if you forgot to shut down your SageMaker serverless endpoint. Don't worry, you will not get charged for it. Okay, so now go to the SageMaker and go to the notebook instance, and then create a notebook instance. Now let's call this as serverless workshop. Let's say live. Keep the minimum instance. Okay, all the defaults looks okay, and yeah, you can also create a new role for this. Okay, it will say these are default permissions or that are required, and then create a role for you. Okay, and yeah, remaining all will be by default. And then your Jupyter notebook will be created for you. So it will take like a couple of minutes to create. So meanwhile, I'll go into the already created notebook instance. Let's go into my Jupyter lab. So what you can do is, since you have cloned the repo, I think this one, and if you actually see the notebook for SageMaker Serverless Inference is there inside this folder. Okay, you can what you can do is you can upload that notebook. Just selecting and open, so it will upload it. I already uploaded it, so it is there for me. And then what you have to do is you just have to run cell one by one. Let's restart it, and then you just have to I think yeah, you just have to install and restart once again, and then run all this one by one. So I'm not doing any training here. I already gave you the trained model as a model artifact for you, so that it will copy these model artifacts to here, and then using this model artifact, it will deploy the endpoints. So what are the steps? First, doing a setup. Import all the necessary libraries, copy this model artifacts from this URL. It will be copied to a local folder. Then upload this model artifact into one of your S3 bucket, and you will get the S3 path here. And then you tell, this is an Hugging Face transformer BERT model. So I will tell what is the transformer version, what is the PyTorch version, what is the Python version. All I am specifying it. And I'm creating a Boto3 client. Another caveat of this serverless preview is that you cannot use SageMaker SDK like this and then deploy a model, but you have to use Boto3 client. But since this is a preview, we have to bear with it. But in future, this will be solved. So when you're using Boto3, then it's a little more step. So I first have to create a model, which means that I give my configure what is the framework I'm using, and what a type of instance I want to use, and yeah, so that is this is my image URI configuration, and then I am actually creating model here only, not here. So and then I say that this is my image URI and this is my model artifact, and then you create a model, and then you create a endpoint configuration, and this is where we will be telling that I need a serverless endpoint, not a real-time endpoint. And then by how do you say, like, you have to give this configuration. Okay, if you say specify this configuration, then it understands that you want a serverless endpoint, not a real-time endpoint. And then you have to give what is the memory you want, whether 6 GB, 5 GB, 2 GB, like that. And then what is the maximum concurrency you want for asynchronous invocation. And then finally create your endpoint. And once the endpoint is created, you should see something like this. Okay, it should be in service. And then once it is there, you can pass some test data and then invoke it. So this is a sentiment classifier. So movie sentiment or movie reviews sentiment classifier. So if I give a positive review, it will tell you like 1. If I give negative review, it will tell 0. And yeah, you can test search the serverless inference, and then finally you can delete all your resources. Okay, any questions on this?
So this question is related to SAM. I think the YAML file plays an important role there, how you have written it. So that part, like if you want to learn properly, what can we do?
Okay, yeah. One second. Just close this. I think this template. Yeah. So so this all are extension of CloudFormation template. So like this is like a declarative programming, and like in CloudFormation template, the only mandatory thing is like you have to define this resources. Okay, and yeah, it actually, I am also not a big fan of these things. I find it very non-intuitive and very tough to code and understand, and it's not human readable things. So I would recommend you to go for AWS CDK, and CDK is also a tool which actually you can create the same CloudFormation template through your favorite programming language like Python. Okay, probably I will do a future session on CDK, but for now it's like you have to understand what is the CloudFormation syntax of creating resources. So in just once again, so in CloudFormation template, so you have many components, and the most important component is your resources, and that is what is given here. And you have to tell like what this is, like what is will be my a name identifier. So I say that this is an inference function. Okay, so I can give another thing, like now I can say S3 bucket, and then I will say what is this S3 bucket. So this I'm saying this is of type serverless function. Okay, so now I can say I need a S3 bucket, which means I have to say, I really do not remember what is the exact syntax, but it might be something like this.
That's fine. I think that
yeah, it's
syntax
something
part
like
we
that.
can figure it. No issues.
Yeah. So then you have to define the properties, like like let's say in S3 bucket it could be what region I want, now what is the encryption I want, like that. So is it Is it a versioning should be enabled or not? All those things you have to do. See, it can go a very long. So this has like only like maybe like 30 lines. I have seen like templates with like thousands of lines, and it's like I don't know like if that is the way, but I actually am not using CloudFormation template. I will use like CDK. So have you are explored CDK?
No, I haven't.
Okay. So if you want to go for, actually these all comes under the umbrella. Oops, what's this? Okay. So this all comes under the umbrella of IAC, or infrastructure as code. And you can also for AWS, the foundation of all this infrastructure as code is the CloudFormation. Okay, but this CloudFormation is written either as a YAML or is JSON, right? So in a declarative way. But these are like very difficult to maintain and to read. So that is why we have an alternative. So AWS comes with this something called CDK, where you can create this infrastructure using your Python code. Okay. Another alternative would be you can just explore Terraform, okay, or Ansible. So these are some other alternatives for your infrastructure as code.
So Bismillah, what is the best in class stack to do DevOps here? Is it CDK, CLI, CloudFormation, or Terraform?
Yeah, CDK will be the
CDK is the best approach. Is it like best practice now in AWS?
Yes. So CDK is considered to be the game changer for infrastructure as code.
Okay.
Thank you so much.
Yeah. Okay. So then I think that's it about it. I'm not sure how much you are able to do hands-on with this, but no, please try on your own. So you have all the instructions in this GitHub repo. Okay, try to follow the instructions and do it on your own. And if you have any doubts, please feel free to reach out to me, and I will be happy to help you. Okay.
So yeah, team, this
Thank
is
you.
quite an extensive process, as you saw. But Bismillah has created a very nice GitHub repo where he explains in great detail how to go about it. So it does need probably more time for all of us to do the whole process. Yes. So any questions now?
Is there any way to give API key and all those things in the YAML file itself?
Mm-hmm. What do you mean? Like you have to add an authorization and
Yeah.
then give this?
Right now, this is an open-ended API anyone can call, right? So if you want to add authorization, API key, and rate limiting and other things, is there possibility to include it in the YAML file?
Yeah. So in this API creation, so you have to specify what authorization you want, and then the API key will not be created. I think it might be the output of this thing, right? So then you can actually share those API keys to your users.
Okay. So there's, some manual step where we need to go and create API key and give rate limits and other things, or my question was, can everything be done in code itself? Is that possible?
Yes. All this will be taken care in code only. So just refer to the SAM API reference or developer guide, and then see the CloudFormation reference guide also, and see how you can actually configure your authorization within this. So this is the place where you have to do. So now it is an open-ended, as you said. but you have to just tell now this should be an key based thing. And then once it creates an API as an output, you have to get the API key as an output and then give that to the user.
Got it. Got it. Thanks. And can you tell a few words about AWS CDK? I don't think I'm very familiar. So when you mean easing this one and using CDK, what do you mean? Yeah.
Okay. CDK is a cloud development.
Cloud development kit, cloud developer kit, cloud developer kit.
Yes. So it is also development kit. So it is the foundation is all the cloud formation, but what happens is that as you know, the cloud formation thing is it's not user friendly, it's not human readable, it's very difficult to maintain. And what you can do is you can use CDK, and once you installed CDK in your computer, you can create CDK using your Python programming language. Okay, so let's say CDK Python API reference, then you will see like how you can create that. So you can go to the AWS CDK, and let's say if you want to create S3, here it is. So let's say this is this Python? No, okay. So this is Python, and then let's say if you want to use S3, yes. Okay, and then what it will do is all you have to do is, let's say this is pure Python code, right? Let's say just imagine I want to create an S3 bucket. I will say S3 dot bucket. That's all I want to say. But if you compare to my YAML template, then you have to write all these things. So I have to say S3 bucket, I have to say type, I have to say property, all those things. And it is in a YAML format. So I have to take care that I use proper tabs. So I cannot do any comments, it cannot be like, and also I cannot do any debugging on this. So I can do debugging on this CDK thing, right?
Got it.
CDK is Python-based programmatic management of all your AWS services. So
yes,
it makes,
infrastructure.
it
yes,
makes it really easy to manage your whole DevOps environment using Python programmatically.
exactly.
Got
In
it.
fact, in CellStrat Hub,
So-
we didn't have CDK. We are moving to CDK in next few months.
Oh, awesome. Okay.
So whatever we did today, that is deploying via SAM as an API, some image processing service, we can do the same thing with CDK.
Yes, of course, yes. So SAM and CDK goes well together. So you can also see some. So you can also create SAM and CDK better together. And read about these blocks.
Got it. Thanks.
So friends, this kind of workshop can assist you in your AWS certification process, right? So that's what we are kind of covering today. It's a pretty extensive one, yes. So you have to try that out. Any questions for today's workshop?
Sir, is it compulsory to actually give our bank details in order to create an account?
Yeah, AWS requires credit card. So I invite you to our second workshop tomorrow on serverless API deployment using our product platform called CellStrat Hub. There also we have an extensive serverless API deployment architecture that actually doesn't need cloud expertise. Everything will be done in a GUI kind of environment. So you can, of course, do whichever option you prefer. But I invite you to our second workshop in this series tomorrow, where we'll be showing the same serverless API deployment using CellStrat Hub infrastructure, which doesn't need AWS expertise or credit card.
Okay, sir. Thank you.
Yeah, I also tried personally the CellStrat Hub, and it is very good. And yeah, tomorrow I think will be a very interesting session to attend by Bhavesh, right?
AWS is, yeah, by Bhavesh. So AWS is sort of the mothership, right? So it's a ocean. In CellStrat Hub, what we are trying to do is simplify the most critical aspects of the AI development and deployment, scheme. And so it doesn't have all the power which AWS will offer directly. But if you want a simplified scheme for things and don't want to deal with so much AWS backend stuff, you can use CellStrat Hub. But if you are having an AWS license and happy to explore its wider capabilities, then you can use the approach shown today. CellStrat Hub also ends up deploying a Docker image on AWS. So really the net end result is same, just a different simplified approach, but with limited feature sets, of course, not so many things which you can do in backend AWS. Okay, any other questions or comments, team, for today? Tomorrow we have one workshop doing serverless AI with CellStrat Hub, which is again on top of AWS only. Any other questions for today for Bismillah, folks? So, okay, so that's about it, I guess. Bismillah, any final comments?
No, thank you for staying with me, and please try. I think all the instructions are there in GitHub. If you want to reach out to me, you can reach out through mail or LinkedIn. I'll be happy to. Yeah.
So Bismillah, thanks for creating that excellent GitHub repo, which has all the steps how to go about this whole process.
Yeah. Okay. Thanks.
Okay then, so we come to an end today. Thank you all for joining, and hopefully we'll see you tomorrow as well. Thanks once again, Bismillah. Excellent work. Thank you.